Hi everyone, and welcome to Cognito Key. Today, we're going to dive into some of the invisible magic that, well, powers our entire digital world. I mean, think about it. We live in this world of just instant connection, right? Movies, video calls, massive libraries of information just flying across the planet in the blink of an eye. But have you ever actually stopped and wondered, how? How is any of that even possible? So the secret, is fiber optics. We send information as little pulses of light. But that just brings up an even bigger question, doesn't it? How do you take something like an electrical signal, say your voice on a call, and actually write it onto a beam of pure light? That's the exact puzzle we're going to solve today. And the answer to that puzzle is a process called optical modulation. And trust me, it's the absolute core technology that makes our modern digital world work. Okay, so what is it exactly? Well, optical modulation is just the process of taking a light wave and modifying it, changing it, with a high-frequency electrical signal that's carrying our information. To put it really simply, it's how we translate electronic data into a message that's literally made of light. Here's a fantastic way to picture this. Just imagine you're using a tiny, tiny flashlight to send Morse code. But instead of sound, you're flickering it on and off at an absolutely unbelievable speed. And by doing that, you're creating a code of light and dark. That right there is basically what optical modulation is all about. All right, so there are two main ways we can actually do this. We're going to start with the first one, which is the most straightforward approach. It's called direct modulation. And the logic here is, well, pretty direct, just like the name suggests. You take your electrical signal, that's your data, right? And you use it to directly power the laser itself. So if there's more current, the laser is on. That's a 1. If there's no current, the laser is off. That's a 0. It's a really simple, elegant cause and effect system. But as it often goes with simple solutions, there's a catch, a trade-off. You see, rapidly turning a laser on and off like this, it isn't very clean. It actually causes the laser's light to kind of spread out and become less precise. This messy widening of the light signal has a name, and it's called chirp. And this chirp effect, it creates a hard speed limit. I mean, once you get to speeds above 2.5 gigabits per second, the signal just gets way too distorted. For the kind of internet we need today, that is simply not fast enough, which of course brings us to a much more advanced method. So now, let's meet the hero of high-speed communication, external modulation. This right here is the strategy that powers the very backbone of our modern internet. Now, the whole philosophy here is completely different. Instead of messing with the laser itself, you just leave it on. You let it produce a perfectly stable, continuous beam of light. And then you place a separate little device in its path that acts like a super, super fast shutter, literally carving the ones and zeros into that steady beam. And because that laser source is totally stable and there's no chirp to worry about, this method can handle much, much higher speeds. We're talking routinely exceeding 10 gigabits per second and going way, way beyond that. This is the tech that's built for the data superhighway. So you're probably wondering, how does this shutter actually work? This is where things get really, really clever. Let's take a look inside one of these external modulators. Okay, so one of the most common types is called the Mach Zehnder Modulator. It's built from a really special crystal, lithium niobate. And this crystal has a super unique property. Its refractive index, which is just how much it slows down light, can actually be changed just by applying an electric field to it. So here's how it works in just 3 steps. First, that steady laser light gets split into 2 identical paths. Simple enough. Second, and pay attention because this is the key part, our electrical data signal is applied to just one of those paths. This changes the crystal and slightly slows down the light traveling through that one path. So now you've got one light wave that's lagging just a little bit behind the other. And finally, the 2 paths merge back into one. And this is where the real magic happens. The magic of wave interference. If those 2 light waves arrive back together perfectly in sync, their peaks line up and they create a bright pulse of light. Bam, that's a 1. But if one wave is delayed, its peak meets the other one's trough, and guess what? They cancel each other out, creating total darkness. And that's our 0. We are literally creating data out of nothing but light and shadow. How cool is that? Now, while that Mach Zehnder modulator is super common, I should mention there's another key type you'll hear about, the electro-absorption modulator. This one works a bit more like a traditional shutter. It uses a material, something like indium phosphide, that can be electronically switched to either absorb the light or just let it pass right on through. So let's just sum this all up, shall we? On one hand, you have direct modulation. It's the simpler, cheaper option for sure, but its speed is limited by that pesky chirp effect, which makes it best for shorter range stuff. Then, on the other hand, you've got external modulation. It's definitely more complex, but its incredible speed and that super pure signal make it the absolute essential choice for the long-haul, high-speed networks that connect our entire planet. I mean, this incredible technology is exactly what's allowing you to watch this explainer right now. But it really makes you wonder, doesn't it? As our hunger for data just keeps growing and growing exponentially, what's next? What new, even more ingenious methods are we going to discover to control light and write our information onto its beams? And that's our look into the fascinating world of optical modulation. If you enjoyed this deep dive and found it helpful, please do me a favor and hit that like button. Share it with someone else who's curious. And of course, subscribe to Kognito Key for more explainers on the incredible tech that shapes our world. Thanks so much for watching.